Hi, this is Mrs. Basin, and today we're going to talk about naming and writing formulas for ionic compounds with multiple charge metals. So we're going to start with learning how to name ionic compounds with multiple charge metals. So like we talked about in the last section, metals can either form one charge or they can form multiple charges. So in the last section, we learned how to name metals that only have one possible charge. So we're talking about metals that were in group 1, group 2, and most of the metals in group 13. Today we're going to talk about how to name compounds for those metals that contain those metals that have multiple charges. So you'll notice that most of the multiple charge metals are found in the transition metals. Not all of them, but that's where most of them are found. And you'll also notice there's a couple more underneath the stair step. And then there's even some in the lanthanides and actinides. So when we name these compounds that have multiple charge metals, the general idea is the same as when we name compounds with single charge metals. So we're still talking first about ionic compounds. So these are still metals and nonmetals. The difference is when you're naming a compound with a multiple charge metal, you have to use a Roman numeral to specify the charge of the metal. So if you have something that has iron in it, for example, there's two different forms of iron, iron 2 and iron 3. So you have to specify in the formula which form of iron that particular formula represents. So we still do the cation first, metal still first, anion is still second, still name of the first, IDE on the second. The only difference is now we are putting in a Roman numeral in parentheses between the metal and the nonmetal to specify the charge of the metal. So here you can see that example, Fe plus 2 is called the iron 2 ion, and Fe plus 3 is called the iron 3 ion. So then for this example, we're still using the anion rules from the previous type of compound. So Cl minus is still called the chloride ion. So here's a chart that shows a few of the multiple charge metals. This is not all of them, but this does show a few of them. So you have chromium, iron, cobalt, copper, and you'll notice that most of these are transition metals. It also shows here that there's an older naming system that used to be used. So what they used to do is they used to change the ending of the metal to specify whether it was the lower charge or the higher charge. So you can see on all of these examples, OUS meant it was the lower of the two charges, IC was the greater of the two charges. But the OUS didn't specify a certain number. It was just the lesser of the two charges. So let's look at a couple examples here. The most difficult part here is figuring out what the charge on the metal was before it became a compound. So there's a couple different ways that we can do that. And we're going to talk about one way that could potentially be easier, but isn't as safe as using this other way that we're going to look at. So for this first example, we know this is going to be copper chloride. Copper is a multiple charge metal. So that means we have to specify which form of copper it is. So when we look at this, the safest way to do this is to look at the charge of the nonmetal. So the nonmetal charges don't change. There's only one possible charge for nonmetals. The overall charge on the compound has to balance to 0. If you know the charge of the nonmetal, then you can use that to figure out the charge of the metal. So in this case, if chlorine is a -1 and there's only one of them, for this to balance to 0, we know that this would have to be copper 1 chloride. In our next example, still copper chloride, but in this case, there's 2 chlorines, each with a -1 charge. So that means the chlorine side is a -2 charge total, so the copper has to be a +2. So this would be copper 2 chloride. Okay, now the less safe way to do this is to almost think of this as uncrossing the charges. Whatever number was down here came from the copper, whatever number was here came from the chlorine. So when you're doing that, that works most of the time, but we'll see some examples here in a minute when that doesn't work. So this whole balancing the charges idea is the safest way to figure out what that charge is. Okay, our next example, we have iron, and then oxygen we know is a -2. There's 3 of them. So that is a -6 charge total. There's 2 irons over here. So for those to balance out, to cancel out the -6, this would have to be a +3 charge. So iron 3 oxide. This one, again, this would actually work if you uncross the charges on this one to see what that original charge was. But again, safest way is to look at and balance out those charges. So the next one, manganese. And on this one, I know oxygen is a -2. So that means manganese would have had to been a +2. So manganese 2 oxide. And then my last one, lead. Chlorine's a -1. There's 4 of them, so that's a -4. Lead would have to be a +4. And again, we're using Roman numerals, so make sure you're using the Roman numeral for 4. So lead 4 chloride. Okay, so just like last time, pause the video for a minute, try some practice problems, then come back and check them. So the first one, cobalt 3 chloride. Next one would be copper 1 iodide. Tin 4 bromide. Iron 2 oxide. So again, oxygen's a -2, so that means this would have to be a +2. This is an example where that uncrossing the charges wouldn't work, so you have to be really careful with those. Last one, same thing on this one. Lead 2 sulfide. Because this sulfur would be a -2, to balance that out to 0, lead would have to be a +2. So again, the Roman numerals specify the charge of the metal. So then that takes us to learning how to write formulas for ionic compounds with multiple charge metals. And really, this is probably easier than writing the formulas for the single charge metals, because on these, when you have the Roman numeral tells you the charge of the metal. So you don't even have to go and reference the periodic table to look it up. So same thing here. Cation first, anion second. So the metal comes first, the non-metal comes second. The charge that the cation forms comes from the Roman numeral. So if the Roman numeral is 1, it's +1, 2 is +2, 3 is +3, etc. You then crisscross the charges once you find the charge of the anion. If the charge was a +1 or -1, then we don't write the 1, just like the rules we used before. If the subscripts are the same, they cancel out. And then an additional rule that is necessary here is if you can reduce the subscripts, then you give the ratio with the smallest whole number. Okay, so let's do some example problems. So cobalt 2 chloride, the Roman numeral tells me the charge of the metal. The charge of the nonmetal we get from the periodic table, just like we did last time. And then we crisscross those charges. So cobalt 2 chloride is CoCl2. Copper 2 sulfide, this tells me copper is a +2. Sulfur is a -2. Crisscross, they're the same, so they cancel out. So CuS. Next one, tin 4 iodide. This is tin +4, oxygen -2. Crisscross, tin 2, oxygen 4. I can reduce those down, so that becomes SnO2. So the Roman numeral tells you the charge of the metal. The nonmetal, you reference your periodic table. Crisscross charges, reduce if you can. Okay, so pause the video, do these practice problems, and then come back and check them. So first one, lead is +2, iodine is -1. Crisscross, PbI2. Lead is +4, oxygen is -2. Crisscross, Pb2O4, which I can reduce to PbO2. Last one, chromium 3 phosphide. Chromium's a +3. Phosphide is a -3. Crisscross, they're the same, so they'll cancel. So CR